cos of theta minus phi. This part cos theta is involved of theta 1 as welcome to P2S Academy. Welcome to my maths class. In the last class, I discussed different forms of trigonometrical ratios of compound angles. Today, in the first part, I shall discuss the remaining part of the compound angle. Then, in the second part, I shall work out few sums. Sine of alpha plus beta plus gamma is equal to cos alpha cos beta cos gamma within brackets tan alpha plus tan beta plus tan gamma minus tan alpha tan beta tan gamma, and cos of alpha plus beta plus gamma is equal to cos alpha cos beta cos gamma 1 minus tan alpha tan beta minus tan beta tan gamma minus tan gamma tan alpha. Now we can deduce easily tan of alpha plus beta plus gamma, which will be equal to sine of alpha plus beta plus gamma divided by cos of alpha plus beta plus gamma. Now putting these expressions on simplification, we shall get the on tan alpha plus tan beta plus tan gamma minus tan alpha tan beta tan gamma 1 minus tan alpha tan beta minus tan beta tan gamma minus tan gamma tan alpha. Thus we have got the identities for sine of alpha plus beta plus gamma, cos of alpha plus beta plus gamma, then tan of alpha plus beta plus gamma. Then we move to second part. First, let us recall the identities for theta plus phi, theta minus phi, means sine of theta plus phi and sine of theta minus phi. This is equal to sine theta cos phi plus cos theta sine phi. This is equal to sin theta cos phi minus cos theta sin phi, and for cos ratios cos of theta plus phi cos theta cos phi minus sin theta sin phi cos of theta minus phi cos theta cos phi plus sin theta sin phi. We have deduced these identities in the earlier class. Now, adding AB and CD respectively, also on taking difference of B from A and D from C, we are going to get new forms, new identities. Now, A plus B will give us. First, I write the result of sum of the right sides. That means 2 sin theta cos phi. That will be equal to sin of theta plus phi plus sin of theta minus phi. If we add these two, then we get sin of theta plus phi plus sin of theta minus phi, that has been written on the right side, and from the left right we get 2 sin theta cos phi. Then if we take the difference, we get sin of theta plus phi minus sin of theta minus phi, that will be equal to 2 cosine theta sin phi. Next we add C and D. Cos of theta plus phi plus cos of theta minus phi twice cos theta cos phi. C minus D will give cos of theta plus phi minus sin of theta minus phi, that will be equal to sin cosine minus 2 sin theta sin. We call these sum product identities. Sin of theta plus phi plus sin of theta minus phi, that is equal to 2 sin theta cos phi. Sin of theta plus phi minus sin of theta minus phi, that is equal to 2 cos theta sin phi. Then cos of theta plus phi plus cos of theta minus phi, that is equal to 2 cos theta cos phi, and cos of theta plus phi minus cos of theta minus phi, that is equal to minus 2 sin theta sin phi. Next we are moving to get new identities. Let theta plus phi is equal to alpha and theta minus phi is equal to beta. Therefore, if we add these two, we get alpha plus beta is equal to 2 theta, from which theta equal to alpha plus beta by 2, and similarly by subtracting we shall get 2 phi equal to theta plus phi minus theta minus phi, that is equal to alpha minus beta. Therefore, phi will be equal to alpha minus beta by 2. Now, if we put these values of theta and phi, we call this as E, K, G and H. Now, putting these values in E, F, G, H, we shall get, therefore, from E, sin alpha plus sin beta is equal to 2 sin alpha plus beta by 2 into cos of alpha minus beta by 2. I have replaced theta plus phi by alpha and theta minus phi by beta, and already we have got the values of theta and phi. We have replaced those on the left side. Thus, from E we get sin alpha plus sin beta is equal to 2 sin alpha plus beta by 2 into cos of alpha minus beta by 2, and it will give sin alpha minus sin beta, that is equal to 2 cos of alpha plus beta by 2 into sin of alpha minus beta by 2. G will give cos of alpha plus cos of beta, 2 cos of alpha plus beta by 2 cos of alpha minus beta by 2. Then H will give cos alpha minus cos beta, that is equal to 2 sin alpha plus beta by 2 sin alpha minus beta by 2 with negative sign. Now, if I write alpha minus beta by 2 as beta minus alpha by 2, actually we can take this minus sign inside this one, sin of alpha minus beta by 2, as sin of minus theta is equal to minus sin theta. Therefore, we can write that 2 sin alpha plus beta by 2 into sin of beta minus alpha by 2. Thus, we have got so many identities, and my suggestion will be, learners, you deduce yourself following the way I have deduced this. Then you can remember this easily. We are going to discuss the application of the idea of trigonometrical research of compound angle. Sometimes the extreme values of such expressions means a cos theta plus b sin theta plus c, where a, b, c are real numbers, are to be found out. we start how we apply the trigonometrical ratios of compound angles to find the extreme values of such expressions. Let let take theta equal to this expression. Now we see this part is involved of theta. Now if we can express this part in the form, say, p sine of alpha plus beta, or p cos of alpha plus beta, or p sine alpha minus beta, p cos alpha minus beta, then we can easily say the extreme values of sine alpha plus beta, or sine alpha minus beta, or cos of alpha plus beta, or cos of alpha minus beta, as we have learned earlier. -1 less than equal to sine of theta less than equal to 1. For any values of theta, of course real value of theta, least value will be -1 and greatest value will be 1. Keeping that idea in mind, we first try to express this part as in the form p cos of theta plus alpha, or something like that. For that we take a equal to r cos phi, b equal to r sin phi. You can also take a equal to r sin phi, b equal to r cos phi. Then a cos theta plus b sin theta becomes r cos of theta cos phi plus r sin theta sin phi. One thing, if we take a equal to r cos phi, b equal to r sin phi, then can we find r and phi? Yes. If we square these two and add, what we get? A square plus b square will be equal to r square cos square phi plus sin square phi. That means r square. Therefore, r will be equal to root over a square plus b square. R, we are considering here the positive value because we are considering r as a distance. Therefore, we are not considering negative value. Therefore, r will be this. And how to get the angle phi? B by a, that will be equal to r sin phi by r cos phi, that means tan phi. Therefore, from that we get the angle phi tan inverse b by a. Though inverse circular function is not discussed, just we use this symbol here. If tan phi equal to b by a, then phi is represented by tan inverse b by a. Now let us come to this point, a cos theta plus b sin theta. We have replaced A and B by these values and get the form r cos theta cos phi plus r sin theta sin phi. Now we take r common factor, then it is cos theta cos phi plus sin theta sin phi. That means r will be equal to this expression will be equal to r into cos of theta minus phi. Now by taking a equal to r sin phi, b equal to r cos phi, we will get sin form. We have got here cos form. Now minus 1 less than equal to cos of theta minus phi less than equal to 1. Therefore f theta will be equal to r cos of theta minus phi plus c. Using this idea, we get minus r less than equal to r cos of theta minus phi, that is less than equal to r. By multiplying r to each part, we get this. Finally, we have got f theta equal to this one. Therefore, minus r plus c is less than equal to f theta less than equal to r plus c. This part will have minimum value minus r and maximum value r. Now, if we add, actually we can write also. Therefore, f theta or add this one as minus r less than equal to r cos of theta minus phi less than equal to r. Therefore, c minus r less than equal to r cos of theta minus phi plus c less than equal to c plus r. We have added here c on each part, and this one is nothing but f theta. Therefore, final step is this one. Now, putting the value of r, c minus root over a square plus b square less than equal to f theta less than equal to c plus root over a square plus b square. Putting the value of r, we get this one, c minus root over a square plus b square less than equal to f theta less than equal to c plus root over a square plus b square. Therefore, least or minimum value of f theta is equal to c minus root over a square plus b square. Maximum value or greatest value is equal to c plus root over a square plus b square. Least value of this expression, which we have taken letter f theta, will be c minus root over a square plus b square, and greatest value will be c plus root over a square plus b square.